Welcome student. Today we will cover here P block elements. In P block element we will cover here some important topics on group number 16, 17 and 18. So today we will begin with group number 16. So in group number 16, which is also referred to as chalcogens, they are also given the name of chalcogens. In chalcogens or group number 16, these are the elements which are present. The very first element is oxygen, second is sulfur, next is selenium, then is tellurium, and the last is polonium. Their symbols are as follow. The oxygen symbol is O, then sulfur S, selenium Sc, tellurium Te, polonium Po. Atomic number are as follow: oxygen 8, sulfur 16, 34, 52, 84. You even don't need to cram this atomic number. You can drive it out from the magic number concept also. Like the first oxygen, its atomic number is 8. In 8, if we will again add 8, then the answer comes out to be 16, which is the atomic number of sulfur. In 16, if you will add here 18, then you get the answer 34, which is the atomic number of selenium. In 34, again if you add 18, you get 52, which is atomic number of tellurium. And in 52, if you add 52, if you add 32, then you get the atomic number. Then you get atomic number 84, which is of element polonium. Now the electronic configuration of group number 16 is as follow: oxygen, its electronic configuration is this helium, whose atomic number is 2. Atomic number here is 8, followed by 2s2, 2p4. Then selenium, its configuration is neon, followed by 3s2, 3p4, and so on. I have written the electronic configuration of all the element. This electronic configuration concept is very useful in determining the group number or a period number of any element. So here the outer configuration is of oxygen is 2s2, 2p4. So if anybody asks you what is the atomic number, what is the period number of oxygen, then to find the period number of oxygen, we go for its principal quantum number, highest principal quantum number. Here the principal quantum number is 2, so its period number is also 2. But if you want to find it out, its group number, then the group number you can also find it out from its outermost electronic configuration. In outermost electronic configuration, the orbitals which are involved are 2s and 2p for oxygen. In 2s and 2p, the total number of electrons are 2 plus 4, 6. So since the last electron has been entered to the p block, so what you need to do is that after counting the total number of electron in the outermost shell, that is 2 plus 4 is equal to 6. In 6, you need to add 10 more electrons. The answer which I get, it will be 16. So the group number of oxygen is 16, which we are studying. So this is the electronic configuration of all the elements, all the members of group number 16. So now we will cover here physical and chemical properties of group number 16. So in physical and chemical property, we will start with the physical properties. Under the category of physical property, we have to study these following parameters. We have to study this following parameter one by one. Discuss these parameters for every element. So let us start with the very first parameter under the category of physical property, that is your atomic and ionic radii. We know that atomic and ionic, we have studied the trend of atomic and ionic radii along period and down the group. We know that along period, if we move from left to right, or from S block to P block, we know that if we move from left to right, then the size usually decreases as we move from left to right. What is the reason behind a decrease in the size? We can explain this concept using nuclear charge. We know that on moving from left to right from the same period, what happens is that the number of shells remains same. For example, let us go for a group number. Let us make a comparison with group number. Now if I make a comparison with group number 15 and group number 16, in group number 15 the very first element is nitrogen, and group number 16 the first element is oxygen. Its electronic configuration, its atomic number is 7. Its electronic configuration is 1s2, 2s2 and 2p3. It says atomic number 8, 1s2, 2s2 and 2p4 is there. What here we count that the number of shells, here the number of shells is 1 2 3, 3 shells are involved over here. Here the number of shells is 1 2 3, 3 shells are involved over here. So here the atomic number. So what happened over here is, here the number of shells remain same, just the difference is that the number of electron in p is 3 and number of electron in outermost shell is 4. Here one electron is extra added to the same shell. This addition of extra electron to the same shell increases the nuclear charge of the atom, which in turn, what happens if the nuclear charge nucleus is present at the center of atom? If the charge on nucleus increases, then what it will do? Its tendency to pull the outer electron it also increases. So in short what happen, oxygen size reduces as compared to the size of nitrogen. But if we go for its trend along down the group, then what we will see that what we will see, oxygen, sulfur, selenium, tellurium. As we move down the group, the number of shells increases